In our previous segment, we discussed about ingesting various data into the large language model, which contains our PDF documents using PyMo PDF. It's a method or a class available with the LangChain. But the problem here is the context of a large language model is 128K. And the context memory, the maximum context memory is 4000. Assume that we have a private chatbot that requires to look at the data from a large data set and provide the answer. In that case, this 128K context memory may not be sufficient. Also, the large language model will always look at the initial data and the end data. So the data in between these 2 points will be missing. And this phenomenon is called catastrophic forgetting. Subsequently, if the half-baked data is fed to the large language model, it may badly impact the accuracy of that particular prediction. So we can imagine what will happen to our end result. To overcome such situation, we are using a vector database. In a vector database, the approach is completely different. So it would be converting the data into embeddings. It's as simple as like you may have a certain set of statements or sentence. We call it as chunks. The whole document in let's say we have a 64-page document or a 84-page document, PDF document. So we will ingest it by page as we have already done it. Then we will each page, each sentences, we will split into chunks. It can be 100 character length or something. Then this data would be ingested to a database. So in a database, we will do the embedding like each chunks will have a certain numbering method, so that let's say we are in the we are categorizing a certain set of fruits. One parameter is what type of object is it. So it's a fruit. That is one category or one dimension. What type of what is the status of the fruit, whether it is a ripe or raw. So that is going to be the second dimension. Third dimension, whether it is a citrus fruit or a non-citrus fruit. That is going to be third dimension, right? Similarly, somewhere around 768 dimensions can support a large language model. Now, let's look at this prediction so that we will be able to understand more. So the first thing is whether it is a fruit and whether it is a citrus. So let's categorize all the citrus fruits in this area and all the non-citrus fruits in this area. So we have a vector database and assume that we are asking about, let's say this 0.95 is orange, 97 is lemon, 810 is some other category of lemon, and anything else in the citrus family. In this case, I'm trying to search for lemon. Assume that the lemon is out of stock, so that I should be able to get the details about any other citrus fruit, because my search is very close to one category, right? How did they define this? Because they converted it into the statement, they have converted it in the form of number, and they have saved it in the database, so that any number which is close to that particular dimension, the database will provide you. There you can define the temperature values the way we can define it in any of our large language model, so that it will provide you the close range values, maybe some 2 or 3 fruits, right? So that from there we can define the context and we can extract the most accurate data. So half of the problem is solved, right? When we query something, the database is providing you some good number of result, right? So the large language model can just process or can stick to that context, and then it can refine the output. So that's the funda behind this vector database. I'm just trying to rephrase the statement once again. It's called a retrieved augmented generation. When we do, we have already ingested the data into the database by doing the embedding. So we have a certain number of sentences. Each sentences we have done certain number of numberings. So those are called embeddings, and it is already in the database. Now I'm asking certain question to the chatbot. So the chatbot will interact with the embeddings. Again, my question will be converted in the form of numbers, or in other words, vectors. This same vector will go and search a query or pass a query in the database. So the database will provide us the information which is close to the search result or the search query. So we would be getting a bunch of data from that rather than uh, passing all the big context or the vast context, right? Now, this data, we would be passing it to the large language model. The model will process it and will provide us the output so that our output would be accurate. In our case, we are going to use FAISS database. This FAISS database is designed and developed by Facebook. It's as simple as like a Facebook AI systems, a search solution. And even we can use ChromaDB. It's another method. And I will leave a link how to install ChromaDB in the Windows machine, because when we do the ChromaDB installation, it used to throw certain errors in the uh, Windows machine because we have to upgrade the build tools. Okay, so we will take this video into two parts. One is the data preparation, especially the chunk preparation. Second is passing the data to the database. And the third is querying it. Okay, let's go back to the demo, and we'll so that we all will be in the same page. Thank you. We are just going to recap, or we are going to resume where we left in our previous video. So we have this workshop done and a PDF document here for Agile practice guide. So we would be specifically asking the questions related to the Agile practice and we'll be getting the answer, right? And we have a notebook here. So let's download our favorite LangChain modules. So from LangChain community, right? Document loaders, we are going to import PyMove PDF loader. Then from LangChain community or LangChain text splitters, import recursive character text splitter. Then from or import OS. For time being, we will focus only on the data ingestion part. Okay. Now, we are going to do a OS walk within this workshop 10 folder. For that, I'm just copying the path. In this case, for root comma dirs directories and files in os.work, and we have to define a pattern, so that I'm going to define r, and here is our full path. And in this case, we are going to get a list of files, and we would be doing a recursive search or a recursive walk inside this workshop 10. So it will list all the directories and files kind of things, right? So I'm going to do again an iteration inside the files, right? So for file in files, right? So here we don't need any IPyNB because we want only the PDF files. So if we are going to do file dot ends with, it's a method, basically a basic Python method. Okay, file ends with dot PDF. If it is a PDF file, we will consider this file, right? So I would say print file, right? So let's look at it. What is happening here? Okay, so we have one PDF file. Okay, I'll go back here again. Now the time is to load our data. So for that, we need move PDF loader, and inside that, if we look at this, we have only this file name, right? So we want the full path. So what we will do, we need to do os dot join os path dot join. Here we need to provide the root of the folder and the file name. So in this file name, we can provide file. So this is what we have now. If we look at it, we can do something like data equal to, let's say, move PDF loader. Once we did that, we have to do a load as well. We have to load the file. Now the part is completed. If we do print data, means it will print the whole parameters, the document, and it will provide you how many pages or the page by page details, like, right? So this way it will be providing you the data. So if you look at it, you will have you will be able to see the number of pages, right, from the metadata. Now that part is fine, but our expectation is this data, we have this data, and we would be going to create a documents list of documents, right? And what we do here, docs dot extend, and we are going to append whatever the data we received from here, right? So remember that you have two parameters. One is you have the metadata pertaining to this file. Also you have the file, the content, that's called page content. Okay, let me show you that, please. Creator, creation date, source, and after that somewhere it should come file path. Okay, total pages, format, PDF, title, agile practice, author, keywords, more data creation, page 0, page content. Okay, so this is your page content. Since it is the first page, you don't have anything in the page content, but from the second page onwards you would be able to see this data, right? So these are the page content. Basically, if you go to the first line of that, you would be able to see that. Indeed, we will look at that later, or even you can try it somewhere. Okay, so here we have the docs. If we look at it, the docs, and see that we have the data. Perfect. So if you look at it, yeah, you would be able to see properly formatted things, right? Clean and neat. Now we are going to do an embeddings. So for that, what we are going to do here is we need to do a next code. So here we have the recursive character LangChain text splitters. So text underscore splitters equal to recursive character text splitter, and we need to define the parameters chunk underscore size equal to, let's put 500 and see, and chunk underscore overlap equal to, I would say 10 percentage. That means 50 percentage of that. Okay, we defined that. Now we will say chunks equal to text splitters dot document splitters. So there will be a parameter called split documents, and what we need to define here, the docs. Okay, so define the docs. The whole document has been ingested it. Let's look at it basically. Here we need length of chunks equal to 568. So we had a 64 page document. So once the 64 page document has been splitted into 568 chunks basically. Okay, and why did we use this chunk overlap? So the concept is like this. Assume that you have a statement like this. This is your statement, and when we do some slicing, the splitting will happen like this. I mean, we are converting it in the form of tokens. So when we do a conversion, token conversion, it will be splitting the statements like this. So at the time, there's a high chance of losing this data or the meaning, right? Let's say I am a Python enthusiast, whatever it is, some spelling mistake may be there. I like Python. So assume that you are trying to create a token. In the token, it may go for I am. This is for 4 characters. So it's let's say that we can create one token, and after space a pi, it's going to be another, and then enthusiast and I like Python. Similar way, it will create the tokens, right? While creating the token, I'm a Python enthusiast. I like Python. Here, enthusiast, I like, right? If we convert it in the form of this way, it will become, it may not be a right meaningful statement, right? So what we will do, rather, I'm a Python enthusiast and enthusiast, I like Python. So that our large language model will come to know that, yes, I like Python because someone like Python. And automatically it will cut this enthusiast statement and or the cut the enthusiast word and provide us a meaningful statement, right? So that's the reason we are using here the chunk overlap, and here we have the chunk size is 500. Perfect. Now let's do the vectorization part. Okay, for that I will take you to a documentation here. That will make your life easier. So for that, let's import few more modules from LangChain community dot in. Let's look at the things basically. Doc store, we are going to do import in memory doc store. This is one of the important thing. Import FAISS this is our Facebook designed and developed vector database from LangChain community. Or let's look at it. What are all the modules basically? Vector stores, right? Dot vector stores import FAISS. Okay, so we have downloaded or imported the necessary modules. We have our text data and we splitted the text data, or other words, we have defined a rule for splitting the text data. Next, we are going to splitting the text data so that we received the data chunks basically. Now, the next step we are going to do here is we are going to create an index. Why did we create an index? Just first of all, we need to create a source path, right? Something we should start from here or somewhere, and we are going to create a some model data here. Okay, so that the next whatever the data you would be passing it, it will take a relation from the 0 0. Also, it will take a distance from the available data, so that it would be so easy for the FAISS database to navigate and figure it out the values which is close to the available data. Okay, so for that we are using index equal to FAISS index flat index dot flat L2 length embeddings embed query. So what I'm gonna do here is, here I'll be taking index equal to, or rather index equal to FAISS index flat L2, rather hello world. I'll say that agile practice source guide. Okay, so we have created an index here. So this is being index is being created now. Okay, excellent. Now we are going to do, we did a mistake as well, just for your information, because we were embedding dot embed query, right? We were supposed to define an embedding. So how do we create an embedding? Embedding equal to, here we have we have to download one embedding. So let's say from LangChain or Llama embedding. Let's see. Let's look at it. Olama embeddings. We have a Olama embeddings here. Next, we are going to do embeddings equal to any name you can provide it. Okay, Olama embeddings dot. So here Olama embeddings we have to provide model equal to, we can use nomic hyphen text embed, and we will use base URL underscore URL http colon double slash localhost colon 11434. Remember that you can use OpenAI embeddings or anything else, since this large LangChain supports this Olama embeddings, and we are using this nomic text embed. We are connecting it into the Llama, because we don't want to create any token in OpenAI, and we don't want to connect it to the OpenAI endpoints. That's the reason we are doing it in this way. Now our embeddings function is ready, or the parameters method is ready. We initialized it, and then we are doing embeddings.embed query agile practice source guide. So this is our index basically. If I execute it, okay, something has happened. Well, nomic text embed is not found. Perfect. So let me look at it. My Windows PowerShell, run as admin. So here I will go and Olama list nomic embed text colon latest. Okay, I should get this. So it is something. The mistake I did it. Nomic text embed. It must be nomic embed text. So that's because we downloaded the model nomic embed text. So my apologies for this typo. So nomic embed hyphen text. So we are gonna save Control S, then we'll go and execute it from top to bottom. First is done. We extracted the document, then a splitting filter has been defined here. We splitted the document, then embedding method has been created or class has been initialized here. Now we are creating an index. So index is ready, perfect. Now we have to go to the documentation again. We are going to create a FAISS vector store. Perfect. So what we are going to do here is, I'll go back to the next. So we have the next part is we have to create a vector store. So in this vector store, the critical parameters are, we are importing the FAISS class here, and embedding function is needed. That embeddings we have already defined here. Next is going to be index. Index has already been created here. Then document store is in memory document store. So that we have already imported here. Next, index to document store ID, so that we are keeping it as empty. So we will execute this. So now the vector store is ready now. Next, our next step is going to be let's scroll it down. LangChain core documents, import documents. That's fine because there's a sample document. If you look at it in our document, we already discussed about the metadata and our page content, right? So we have a list of metadata and the page content that's called chunks. All right. So now what do we need? Let's examine that chunks. If you look at it, this is in your document, you have metadata and you have whatever you need, everything is there. You have the file path and you have finally the page content. So whatever they requested in the document, everything is there. And we have the index IDs, everything. So that we are good to add the things into the document store. So let's go and add that, please. We are going to do or add the documents right in this. Next is, let's say that data underscore ingest equal to vector store dot add documents, and here the item is documents. It must be a list of documents, right? So what we are going to do here is documents equal to chunks, right? Because in our keys we have chunks of data with the properly formatted, and it's available, right? These are the document is its parent. So we ingested the data. Well, it's going to take some time. I'll pause the video for a minute to complete the data ingestion because we have somewhere around 800 plus tokens. So the data has been ingested successfully. It took somewhere around 1 minute, 24 seconds. So we have to note down a couple of parameters here because my system is having less compute power, and I'm using in-memory doc store. Suppose if it is a Chroma DB or something, it would be persistent, I would say. Okay. Now, how do we search the data? Somewhere here, we have a similarity search, right? For that, data or the question, let's say that question equal to what is agile, okay, and answer equal to data ingest dot or the vector store dot. Here we should have the search parameters or the search, and here we should pass basically the query equal to question, and k equal to, let's say we can say 3 answers, and we should provide a similarity. Search type can be similarity, so that we will get some good. Search type equal to similarity. Okay, so this is fine. So it's searching what is agile. Now we are going to print answer. Okay, so we have received an answer here, and let's do this way. Print answer dot content, or let's see what is there inside. Creation time, page content, agile manifesto. Okay, so let's figure it out. What is that? For elements in answer, print elements. Okay, so here we need to print elements dot page content. Excellent. So if we look at it here, the agile manifesto, agile coach, an individual with knowledge and experience in agile who can train. So this way we would be getting the content. So this much content has been extracted from the database. So this content we would be transferring it to the large language model to do a further process and augment the next generation, or the next generation response to the end user. And we should remember one more thing here. So these all are the chunks, right? Let's look at it. How many chunks are there? Length of this answer. We have total three answers as we mentioned here. If we put 5 and execute it, we will be getting somewhere 5 answers. So that will affect the quality, right? Suppose if you want to give a vast uh, context, in that case you can increase this k equal to 5, that value, so that according to your compute power and the model context memory you can pass these parameters. So this way we would be ingesting the data, and we would be searching it in the vector store. So nothing to worry here. This is we are using just a document store in memory doc store. As I have promised, we would create either a PostgreSQL or a document DB in the upcoming sessions, and we will explore more. Especially I promised you that we would be creating a chat conversational history in a persistent storage rather than a data store file, right? So these all we will move it to the database once we attain some stability on it, because we have to discuss few more parameters, especially this tool callings and agent callings. So I hope this is somehow helping you to understand the key concept of vector database. And remember that we are just offloading the context, right? The database will itself will provide certain amount of data. That data only we are passing it to the large language model, so that from there it can pick, or it will have very good answer and already processed answer. So all the large language model need to do is to process the response and deliver it to the end users. That makes the large language model's life easy, else it may land into the hallucination mode. Okay, so that's it from my side today, and we will come up with another interesting topic. And we have a lot to do with this tool calling and agentic AI topics. So I hope it would be much more interesting, and wishing everyone a very nice weekend. Thank you so much for your time. Bye bye.